Welcome to the third video for Suricata, and for this video I will be analyzing a Trojan spyware sample with my Suricata network analysis tool. So firstly, I've fired up the Suricata executable, and we can see here with confirmation that the engine has been started. And knowing that it is now going to be capturing any network traffic, I can unzip my Trojan and run it as admin, and I'll run anyway. And to confirm that the Trojan has executed and that Suricata is logging any network traffic, I'll load my PowerShell script, which is waiting on the log file, and I can see here there are a lot of alerts that are being flagged from the emerging threats rule set. I'll let this run for a minute or two before I ingest it into Evebox. After letting the Trojan run and Suricata capture all the network traffic, I've loaded the eve.json file into Evebox and made sure that I've set the duration of alerts to the last hour. Starting from the bottom, we can see a number of alerts have been generated notifying of an IP lookup on the domain ip-api.com. The activity is related to an external service that performs IP address lookups, often used for determining geographic locations, ISPs, or other metadata about an IP address. The potentially malicious use of this alert is that, if unexpected, it could indicate that a Trojan or unauthorized application is trying to obtain information about external IP addresses. This is possibly used for command and control, communication, or to mask its activities. Scrolling up, we can see that the next notable alert is a DNS query to a .pw domain, and it's been tagged as likely hostile. This query involves a domain that uses the .pw top-level domain. While the .pw is intended for professional use, it has garnered a reputation for being associated with malicious activity. The potential threat in this alert is that the domain has been identified in threat intelligence feeds as being involved in activities such as phishing, malware distribution, or other malicious behaviors. Domains with the .pw ending have been frequently used for malicious purposes, making queries to these domains a significant concern. This Severity 1 alert that the emerging threats rule set has detected, deleted likely evil exe, download from a number of characters, non-exe extension M1, shows that a potentially malicious executable file has been downloaded on my virtual machine using this character set object. This is often associated with scripting in web environments, and particularly in Internet Explorer. This character set object is commonly used in scripting for making HTTP requests. If an executable is downloaded this way, it can bypass certain security measures, and the non-exe extension suggests that the file may not have a typical executable file extension, like exe, and this is a tactic used to disguise malicious files. The HTTP URL is very suspicious, with nano download partner and campaign all keywords, and the hostname of webcompanion.com is something that we should keep in mind for alerts that are following later on. It then shows an alert for a served attached HTTP from the same hostname, webcompanion, and it installs a malicious exe or DLL called WC installer from this URL. And then the following alert is the confirmation that this malicious executable was installed. And again, we have the same source IP with the same host name, same URL, and same file name. An alert that occurred 5 times is the deleted hash scanner WordPress WP login Firefox 40.1. And this shows that a request related to scanning for vulnerabilities in WordPress sites has been detected. A breakdown of this alert includes the hash, and this likely refers to the unique identifier associated with the request for the detection rule. Scanner indicates that this request is likely part of an automatic scanning activity, and this is typically performed by attackers seeking vulnerabilities. The WordPress WP login page points to the login endpoint for WordPress sites, and this is a common target for attackers attempting to gain unauthorized access. And finally, the browser being used, Firefox, is using an outdated version. The detection of a scanner targeting WordPress login pages suggests that there may be an attempt to exploit vulnerabilities or brute force credentials. Because WordPress is a popular platform, it makes it a frequent target for attackers who scan for WP login access as a common tactic to find weak passwords or known vulnerabilities. An alert that has been present in all 3 spyware samples is this GPL web client webbug 0x0 GIF attempt. Touching on it again, it indicates that a web client has attempted to load a web bug or tracking pixel The 0x0 GIF refers to a GIF image that is 1 pixel by 1 pixel in size, and this makes it nearly invisible to the user and is commonly found in tracking and analytics. This alert shows that an attempt was made to load a tracking pixel, and this can be part of a broader tracking or data gathering effort. Then some alerts that Suricata has flagged in the network traffic is another zip file that has been downloaded and a zip exe in transit. These two alerts show that this source IP of 23.216.6382 to my VM's IP address of 10.0.2.15 has installed a zip file, and then you can also see that in transit is a zipped exe en route to my virtual machine. And this happens again and again. Looking into the P2P Microsoft Voodoo piercing is something that a keylogger could potentially leverage for malicious purposes. The way that it might happen is through data exfiltration. If a keylogger captures any sensitive data, such as usernames or passwords, it could use P2P communications to send that data to a remote attacker without going through traditional channels that might be monitored. It's used for obfuscation. Because P2P protocols help the keylogger, it can use P2P channels to send stolen data back to its command and control server, making it harder to detect since the traffic may blend in with legitimate update traffic. Its obfuscation of communication masks and makes it more difficult for security tools to recognize malicious activity, helping the Trojan evade detection by firewalls or IDSs. The Trojan can use the P2P to receive updates or additional payloads from other infected peers, and this allows it to modify its behavior or install additional malware without relying on centralized servers. Because Trojans are designed to propagate, it could use P2P to infect other machines within the network, thus leveraging legitimate file sharing capabilities to distribute itself.